हेलो बच्चों, क्या हाल चाल? मस्त एकदम. So once again welcome to my fresh episode. Today topic about atomic spectrum, hydrogen spectrum. How many spectrum possible in a series? Today we will learn. Are you ready? Let's start about atomic spectrum or hydrogen spectrum. Students, take a tube. In a tube, put a gas, an amount of gas. Suppose we give some amount of heat to that tube, the gases are converted into rays, some rays. Students, suppose after absorbing heat, the gas molecule converted to rays. Suppose violet, indigo, blue, green, yellow, orange, red. All rays are emitted after absorbing heat. So this, in case of all rays emitted, we call this continuous spectrum. And suppose students, if blue, green, gaib and violet, indigo, yellow, orange, red, all five rays are emitted, then we call this line or discrete spectrum. These are all about continuous spectrum and line spectrum and minimum fundamental of atomic spectrum. Suppose students, this is an atom. Let us not consider an atom. Suppose we give some amount of heat. Students, this is the diagram of atom. First cell, second cell, third cell. First energy level, second energy level, third energy level. First energy levels contain minus 13.6 electron volt, then minus 3.4 electron volt for second energy level, and third energy level minus 5.1 electron volt. Students, these are in the first cell. Suppose 2 electron is present. We give some amount of heat and that cell's energy is minus 13.6 electron volt. So when this electron absorbing energy, when we give the amount of heat, that electron absorbing energy, when after absorbing that energy increased to minus 1.1 electron volt. In the primary stage, that cell's energy, that electron's energy minus 13.6 electron volt. And after energy absorbing, the energy increased to minus 1.1 electron volt. Then that electrons jumps to third energy level, because the energy of first this electron equals with third energy level. Okay. So, but electron tries to placed with lower energy level. So this is higher energy level. So electron tries to remain with lower energy level. So because of this reason, that electrons can satisfy to place to stay in this position. So that electrons returns back to the primary position, and the absorbing energy is released, is emitted in when that electrons returns back in the form of radiation. In the form of radiation or electromagnetic wave, that electrons returns back and some amount of energy is released in the form of radiation or electromagnetic wavelength. Means some radiations are released and electromagnetic waves are released. Students, a question: an electron in hydrogen atom jumps from n equal to 2 to n equal to 1. Find the energy of wavelength of emitted. Means, what is the meaning of that question? Students, electron jumps from n equal to 2 means second energy level to n equal to 1 means first energy level. This is second energy level, this is first energy level, means that electron jumps from second energy level to first energy level. So what is the how many energy emitted? First question, how many energy emitted? And second question, find the energy of wavelength emitted. First question, how many energy emitted, and second question, find the energy of the wavelength emitted. Okay, so students, total energy del E equal to E2 minus E1. Okay, so energy for nth cell equal to minus 13.6 z square by n square electron volt. Students, delta E equal to E2 minus E1. So delta E equal to E2 means minus 13.6. Z square means Z value 1 because hydrogen atom, in case of hydrogen atom. Okay, Z square by N square means 2 square minus E1 minus 13.6 1 square by 1 square. And whole answer is 10.2 electron volt. So energy emitted equal to 10.2 electron volt. Then students find the energy of wavelength emitted. So lambda, so delta E equal to hc by lambda. So students, h equal to Planck's constant, c equal to velocity of light. This is a constant term. Remember now that this is constant term and this is the what is the value of hc. Hc value is 12375. Okay, this is students E. This is the energy. So this energy answer opened with electron volt, and this is lambda. Lambda answer opened with angstrom. So we can calculate the wavelength emitted. So students, E equal to hc means 12375 by lambda. Then student, energy equal to 10.2 equal to 12375 by lambda, which means that lambda equal to 12375 by 10.2 electron volt angstrom. This is how we can get the answer of find the energy of wavelength emitted. So this is first answer and this is second answer. Students, electron jumps from n equal to n2 to n equal to n1. So students, delta E equal to E n2 minus E n1. So when energy converted to radiation, energy converts to radiation. hc by lambda equal to minus 13.6 z square by n2 square minus 13.6 z square by n1 square. So hc by lambda equal to minus 13.6 z square by n2 square minus plus 13.6 z square by n1 square. Then hc by lambda equal to 13.6 z square common, then 1 by n1 square minus 1 by n2 square. Then students, according to our ambition, hc by lambda equal to, in this multiply hc 13.6 z square and divide hc. For our answer, 1 by n1 square minus 1 by n2 square. Then hc subtract, then 1 by lambda equal to 13.6 by hc z square, 1 by n1 square minus 1 by n2 square. Students, 1 by lambda equal to 13.6 z square by hc into 1 by n1 square minus 1 by n2 square. Remember the thing, 13.6 by hc, this term equal to r equal to Rydberg constant. Then 1 by lambda equal to rz square into 1 by n1 square minus 1 by n2 square. This is our atomic spectrum formula. Formula of atomic spectrum. Then students comes to the main topic of atomic spectrum. So students, this is a diagram. So this is energy levels. This is first cell, second cell, third cell, fourth cell, 5 cell. N equal to 1, 2, 3, 4, 5. Energy levels are electron volt, then 3.4, then goes on. Students, these are first energy level when electron returns back or jump from second energy level to third energy level, second energy level to first energy level, third energy level to first energy level, fourth energy level to first energy level, fifth energy level to first energy level, then infinite energy level to first energy level. In this diagram and in this statement we call Likun series. Okay, and students, when this electron jumps from second energy level to first energy level, some energy is emitted and some waves or some radiations are also emitted, and these waves are called Likun waves. And that waves or that spectrum, these are student series. And these spectrum are found in the only ultraviolet region. Students, calculate lambda wavelength when electron excites from n equal to 2 to n equal to 1 in Likun series. Okay, n equal to 2 to n equal to 1 means electron jumps from second energy level to first energy level. What is the value of wavelength? Students, this is the atomic spectrum formula. Okay, then 1 by lambda equal to r z square 1 by n1. n1 means 1 square minus 1 by n2 2 square. Then 1 by lambda equal to r 1 minus 1 by 4. Then students, 1 by lambda equal to r 3 by 4. Then students, lambda equal to 4 by 3r. Students, in this situation, not remember only r value, remember 1 by r value. So what is the value of 1 by r? 1 by r value equal to 911 angstrom. Okay, put the 1 by r value 911 angstrom in this statement. Okay, then students, lambda equal to 4 by 3 into, in place of r we can write 1 by r. Then students, lambda equal to 4 by 3 into 911 angstrom. Then lambda equal to, students, 4 by 3 into the value of 911 is maybe 912 for subtracting angstrom. Then lambda equal to 4 by 304. Then students, 4 into 304 angstrom equal to lambda equal to 1216 angstrom. Okay, so the lambda value of first energy level is 1216 angstrom. Then we can calculate the lambda value of this transition, then this transition, then infinity to fast transition. If n equal to 2 and n equal to 1 means electron jumps second energy level to fast energy level. This transition is shorter, but the wavelength of this shorter transition is highest, 1 to 16 angstrom. If n equal to 3 and n equal to 1 means electron jumps from third energy level to fast energy level, then the wavelength is 1026, means if transitions is increases, then wavelength value decreases. Then in the infinite, when electron jumps from infinity energy levels to fast energy levels, then the wavelength is 911 angstrom, means the highest transitions have the lowest wavelength value. So students, delta E is inversely proportional to hc by lambda. Friends, there are 5 series present: Likun series, Balmer series, Pascal series, bracket series, and P-Fund series. When electrons are jumps from any energy level to fast energy level, then we call this Likun series, any energy level to fast energy level. And second, Balmer series, when electrons jumps from any energy level to second energy level. Any energy level to second energy level means in this n1 equal to 2, in Likun series n1 equal to 1, and in Balmer series n1 equal to 2. Means electron jumps from any energy level to second energy level, then we call this Balmer series. And students, in third Pascal series, n1 equal to 3 means in any energy level electron jumps from any energy level to third energy level. Second energy level and fast energy level is not works in case of Pascal series. Then students, comes to bracket series. In bracket series, n1 equal to 1 and n1 equal to 4 and n2 equal to more than 4, 5, 6, 7, 8, means electrons are jumps from any energy level to fourth number energy level. In this, n3, n2, n1 are not works. Okay, then comes to P-Fund series. In P-Fund series, n1 equal to 5, 1, 2, 3, 4, 5, n1 equal to 5 and n2 equal to more than 5, means 6, 7, 8, 9 up to infinity. Students, in P-Fund series, electrons are jumps from any energy level to 5 number energy level, and in case of P-Fund series, n4, n3, n2, n1 are silent. And students, when electron jumps from second energy level to fast energy level, or third energy level to fast energy level, some amount of energy is released in the form of radiation or electromagnetic wavelength. So in these students, spectrums are found in ultraviolet region. In Likun series, spectrum are found in ultraviolet region, and in Balmer series, atomic spectrums are found in visible region, and in Pascal series, infrared, then infrared. Students, before we calculate the wavelength value of only Likun series, and according to calculate the wavelength value of Likun series, in this style we can calculate the wavelength of this except 4 wavelength, 4 series of wavelength: Balmer series, Pascal series, bracket series, and P-Fund series wavelength. We can calculate the style of Likun series. Students, how many spectrum possible in the given energy level? Means suppose n1 equal to 1 and n2 equal to 4, and another given is n1 equal to 5 and n2 equal to 16. Okay, so in first example, electron jumps from 4 energy level to first energy level. So how many spectrum possible? So spectrum calculated formula equal to n into n minus 1 by 2. Students, n equal to outermost cell. Outermost cell or outermost energy levels. Okay, so in first example, outermost cell equal to 4, then formula n into n minus 1 by 2. 4 into 4 minus 1 by 2 equal to 4 into 4 16 minus 4 by 2. 16 minus 4 12 by 2 equal to 4. When n1 equal to 1 and n2 equal to 4, in case of this 6 spectrum are possible. And student, if n equal to 5 and n equal to 16, how many spectrum possible? So formula equal to n into n minus 1 by 2. So 16 into 16 minus 1 by 2. Then students, 16 into 16 minus 1 by 2 equal to 16 into 16 256 minus 16 by 2 equal to 240 by 2 equal to 120. Means when the electron jumps from 16 energy levels to 5 number energy levels, then 120 spectrum is possible. Okay, when students transition is decreases, then in case of lower transition wavelength is higher, and in case of higher transition wavelength is lower. Okay, so these are all about atomic spectrum. About my class, comment me. Meet again with another concept. Thank you.